Okay, this is going to be a longer video, and it's going to be something that has just kind of a culmination of a lot of the things that I've discussed before as far as the universe and physics and things that a lot of other people haven't recognized. They'll first start about the solar system. And like I discussed before, the Earth is negatively charged. So obviously it's an electron, 8 planets, that's an oxygen atom. Previous videos I called it a molecule. That was a mistake on my part as far as terminology goes. The sun recently did a pole shift, and you can look at gravity as a larger version of magnetism that we see on a smaller scale that we recognize when it comes to iron-based and rare earth-based magnets that we create. And so when poles flip on magnets, the other one that there becomes resistance, and so the other one has a propensity to want to automatically flip. And so after the sun flipped its poles, obviously we're going to have there's the assholes that are honking and making noise. I don't know if you heard that, but we'll listen to the video later on. That's part of the harassment campaign that I deal with, is these honking assholes that walk by, or that drive by with semis early in the morning. It's like, what, 7 right now, so they used to do it at 3 or 4 in the morning, and they're fucking garbage people. Anyways, we'll get that cleaned up, because as soon as I talk to the right people, these people are going to basically be, well, they're going to enjoy the cages that they put themselves into. Back to what I was saying. When you have a pole flip on magnets, the opposite magnet has a tendency of wanting to right itself and flip in the direction to where the magnetism becomes where they connect with each other versus repel each other. And since the sun recently turned its pole upside down, it switched poles. That's probably the reason why we're seeing such an erratic behavior of our north and south pole alignment. And also that's gonna affect the things like the trade winds and our the cosmic radiation coming in. We have UVC coming in, touching the ground, which is something that hasn't happened in I don't know how many generations before us, but in the generation of people that we're seeing in this day and age, it hasn't happened for I don't know how many hundreds of years before this generation. So that's kind of an implication that our magnetic shield is somewhat weakened or unstable. So you see an unstable magnetic shield around the planet with cosmic radiation such as UVC hitting the ground, and you're seeing the north and south poles, the magnetic north and south pole, moving very erratically over a short period of time. So you can kind of compare that to a smaller scale of what magnets do when we have them in our hands and we flip them. Now that also has a comparison on a larger scale to an oxygen atom versus our solar system. And I recently realized that from some information I kind of was listening to and looking at what you would call simulations of scenarios in the solar system according to physics, what would happen if Jupiter wasn't as large as it was, or if it wasn't there. And so Jupiter has a massive magnetic pull, or a gravitational pull, that keeps the asteroid belt in between Mars and Jupiter stable in its position. And so if Jupiter wasn't there, all of those asteroids in the asteroid belt would go awry and start acting in a way to where they wouldn't be stable enough to stay where they're at, and it would cause all kinds of catastrophes and havoc, hitting planets all over the place. So Jupiter, in effect, is the large planet of our solar system that defines the inner layer of electrons and the outer layer of electrons, if you look at it on an atomic scale. And I believe the outer layer is called the valence. It's like the valence cloud, the valence, I forget the terminology, but the correct term is the valence. I think it's called a valence cloud. It's the outer layer of electrons in an atom. And so you could say in our solar system, the asteroid belt is what defines our inner layer and outer layer of planets, or inner layer and outer layer of electrons. So when you look at the difference between the larger scale and smaller scale between magnetism and gravity, and the inner scale and larger scale between an atom and our solar system. They're very similar. And there's an old saying that says that history doesn't always repeat itself, but sometimes it rhymes. And so this is kind of what I'm getting at. The way that I see things is that it's like fractal imaging with mathematics. You might want to look up what a fractal is if you haven't done that already. If you've been listening to my videos, you probably have already studied that. As you go in infinitely inward to a smaller scale, we have a similar representation of what we see on a much grander scale around us. So the atoms that we don't see, that we can barely see with our micron or our atomic microscopes, are very similar to the same thing we see with our largest telescopes. And my theory is that these are barriers of different universes. And so similar to a black hole having what you call an event horizon, there's an event horizon as you get down to the atomic scale where physics starts breaking down and a different form of physics starts to apply. And that would be what you'd be calling an event horizon, going into a different universe. And same with outward. Once you start getting into grander scales of planetary bodies and planetary objects, something like along like a neutron star, a pulsar, and black holes, physics kind of starts to break down according to what we have as far as our equations go. And so you can see both inward and outward, both on the atomic scale and the scale of the size of the universe, that we're inside what you would kind of call a bubble, a physics bubble that works for us within the boundaries of what we can see and we know. And as we get to those event horizons, our physics system starts breaking down. And I expect that those are the barriers in which you would achieve the ability to transfer or transport into a different universe. And you can further extrapolate with that type of assumption. We're calling it an assumption right now because it's not a theory, it's a hypothesis. You can extrapolate with the hypothesis under these circumstances that we can only look so far when it comes to an atomic microscope, as well as something like the Hubble telescope, out so far that these universes at these event horizons probably go indefinitely outward and indefinitely inward. And so when they talk about infinity universes and stuff like that, there's a potentiality for that happening, but I don't think it's in the way where people think, where we just transfer over into a different universe or a different reality, like switching from one bubble to another. I think what we're looking at is that we're inside a bubble and there's many bubbles around us, like you've seen the way that's been portrayed before, like we're kind of in like a bubble bath and we're inside one bubble and there's many bubbles around us. Something similar to that. But also, it could just be something where it indefinitely goes outward and expands infinitely, as well as expands inward infinitely. Just a thought. But as I start seeing things match up, like gravity and magnetism being similar but not acting in exactly the same way, and also an atom versus our solar system planetary structure and bodies acting similar but not in the same way, you can kind of see that we're looking at a grander scale and a smaller scale of the same thing that we know as what is our reality and our physics system that works within the boundaries of what we can observe. Anyways, I hope this helps somebody who actually has a degree and can further this forward. It's kind of something that when it comes to putting into an equation or coming up with the concepts that actually explain this in mathematical form, is beyond me. But the idea is definitely something to sit around like MIT lunch table to kind of figure out where to go from here in understanding precisely how we want to look at the universe. Anyways, have a good day. Hope this doesn't make you think too hard.